In this video, I'm gonna talk to you about the product AX, where A is a matrix, A, and then X is a vector. I'm gonna talk about the product, what it means to be a product, and that is called something. We will learn that that's called a linear combination of column vectors. And this whole thing is called, the product is always called a dot product for in what we're gonna learn. And we're gonna learn that this is a concept that is very important in linear algebra, and you're gonna see it many times. So let's define the dot product. So the dot product of two vectors, let's say we have vector B with vector W. Where B and W could be column vectors or row vectors. What we're gonna do is that let's say, so BW, the dot product is defined as B1 times W1 plus. Let's say we have n vectors, so we're gonna do Bn Wn. We have n entries in the vector, in each vector. So remember, we need to have the same number of corresponding elements in B and W in order to compute the dot product. So the dot product is always a scalar. We know that in algebra we learned that the product of two non-zeros numbers cannot be zero, but here the product of these vectors could be zero. This could, so here we cannot have, but here could be zero. That's a amazing fact about products in matrices and vectors. So let's say we have vector 1, 2, 3, and when we have vector 2, 2, 2, this is your B, this is your W, then B W, the dot product is gonna equal to 1 corresponding, okay, 1 times 2 plus 2 times 2 plus 3 times 2. And that's equal to 1 times 2, 2 plus 4 plus 6, and that's equal to 12. So notice it agrees with what we said. It's a scalar. 12 is a scalar. So the dot product is equal to 12. Alright, so knowing this fact and this definition, we're gonna expand it to the product of AX. So let's say we have a matrix that looks something like this. We have 1, 2, 3, and then we have 2, 4, 2. Let's say this is your A, and then your x vector is gonna be something that, okay, how many columns we have here? We have 3 columns. What that means is that we need to have something that looks like this. X1, X2, and X3. So now the product of a linear combination is gonna look something like this. We can write it as a linear combination of X and A. So that's gonna be, so first of all, we're gonna have X1 times 1, 2, 3 plus X2 times sorry, let's skip it, just X2. Okay, so now we're gonna have X1 okay, let's see. Okay, let's keep the X3. Okay, so we're gonna have X1. Remember, when we have the coefficient here, we have coefficient matrix. We have, this is your X1, this is your X2, this will be your, this will be your, you can say this will be X1, Y2, or X1s. Okay, I'm gonna keep it simple. This will be X1, X3. So this will be your first row, and first column. Okay, so that will be X1 times 1, 2 plus X2 times 2, 4 plus X3 times 3, 2, and that should be equal to a scalar, a vector scalar, yeah. So what you do is that the dot product is gonna be equal, so first you distribute this scalar here into the vector, and then you do the same thing for all of them, and then you add corresponding rows, and you're gonna get a vector. So this here is called a linear combination, but if you want to put it in compact form, that's gonna be a vector in terms of X1, X2, and X3. And of course, each entry, you're gonna have 3 entries. You're gonna have two entries, and then those 2 entries are scalar. This is a scalar, and this is a scalar. So let's look at an example. Okay, let's say your A looks something like this: 1, 2, 3, this will be 2, 5, 2. Then your x vector something like 1, 3, 5, 1, 3, 4. Then the dot product is gonna equal to, as a linear combination, is gonna equal to, okay, so we have 1 times 1, 2, plus 2, 5, and then the 3 here, plus 4, 3, 2. So that's a linear combination. Okay, so now we wanna get an answer. We're gonna multiply this, so that will be 1. 1 times that will be 1 over 1, 2. Then 3 times 2 is 6. 3 times 5, 15, plus 4 times 3 is 12. 4 times 2 is 8. So 12 plus 6, 18, plus 1, 19. Then 2 plus 15 plus 8, that will be 15 plus 8, that's going to be equal to 23 plus 2, that's 25. So that's the dot product. You can notice these are scalar, this is scalar. That's all I wanted to teach you on this video. Thank you very much. Don't forget to subscribe, please.